Okay, formally good evening, everyone. We have, let's say, quite ambitious agenda today because I want to go just to make a short overview of what we've been doing in the last 2 weeks, this week and the previous one, then move to what is DashDB in memory analytics, and then do the specific walkthrough in DashDB. So since previous week, we start talking about, well, for 2 weeks, we are talking about natural language processing. And I think most of you understand why we are talking about this in a class of big data analytics. Our first discussion was very, let's say, intense, active, and I guess fruitful for everyone. And we ended up with the conclusion that the big chunk of data, 80%, is unstructured data, and the big value of data is in this unstructured data, and a big chunk of this data is just written documents which are in have to be interpreted in the natural language processing techniques. So that is the connection. What we are doing today in big data analytic class is trying to heavily orient to what businesses are looking to. The big chunk of information they are having is not in the structured way, which is presented here in the structured table, which has a column of person and organization, and you easily can identify that Welsh is run the organization, which is GE. Most of the information today in businesses is in the way which is to the right, which is totally unstructured take. You can think about all the information in blocks, all the records, health records, or all insurance claim, which is text and images as well as the healthcare information. And if you go to policy in cybersecurity, in government, if you go to let's say procedure, maintenance procedure, wherever, in whatever business you turn, the big chunk of information businesses hold is in this unstructured form, which is presented to the right. And from the previous weeks, we know all the difficulty to process and understand natural language processing. So I think this part is clear. I guess everyone is on board of this, and you understand that the main component of the natural language processing, from starting with the simple lexical analysis going to the syntactic and semantic analysis, we end up with what is the inference, which is, let's say, the most important thing of knowledge, which we as a human use the language to understand our environment, to understand, to communicate each with other. And at the end of the day, we are able, based on all the information we are receiving, to infer a conclusion, which can be, when we talk about natural language processing, to answer a question. Okay, well, a simple inference, let's say, it stopped raining. What you think? Well, it was raining before. Just very simple thing. What is inference to the most complex, when we have to, let's say, to apply all the knowledge we have to infer some conclusion and to answer certain question. So this is the most important part. And of course, everything we interpret as a human is in the context. And here I have something in bold, which I want to point to this out, which is the quite important thing about the context. When we talk about, we analyze the text in the context, because in another context, it can have totally different meaning, starting with, let's say, he's hot. We can talk about a child which has fever, or we can talk about someone is outside with 100 degree in Washington D.C. in July, and it depends in what context we are using this expression. So, but the context is not only about the present, the context expands in time and in all the knowledge. When we talk about in context, sometimes the context is totally historic, has nothing to do with the text we are talking about. It relies on some previous knowledge historically, or just in general historical knowledge we as a human have. This just I want to summarize here the challenges of natural language processing in parallel with the importance to get value of data for what is important for the today's businesses, what they are looking for, and why in this class we are focusing in these topics. So up to here, any question? Because I'm going to go like the first part, the review, most interactively. If you want to just clarify something, you are very welcome. You can unmute yourself and talk, but just one by one, please. Okay, by here, nothing. So we go to the paradigm shift of in computing. Very in my point of view, very well presented here in this picture. The first 40 years of previous century was the tabular computing, then the programmed computing, which we still enjoy it. That's are the computer we are working today with. And in the last few years, the cognitive computer, which is presented in the last picture. I said presented in the last year, even though the research to support development of cognitive computing started long ago, because it's based on accumulate knowledge in machine learning, artificial intelligence, but the technology few years ago made possible the real implementation of all the knowledge acquired toward this new way of computing. So let's say the first one was there were several cognitive computing, starting with chess player, and then the most, let's say, significant one in the last year is the Watson cognitive computing. So when we talk about this transition of computing, we have to be aware that these are three different eras of computing, and we are in the new era, even though we still enjoy the power of the programmed computing, and this will be for long, because let's say a cognitive computer is paradigm shift to new way of computer, to because the computer was built by the human for the human to help us, right? Now, they different computers are helping us in different way. Programmed computing helps a lot in all these tedious activity which can be programmed, very heavy calculation, solving of differential equation, and heavy scientific calculation. So they are very helpful in this direction. That was the main reason of perfectioning the programmed computing. Now, with the wealth of data, which is the wealth of big data, the complexity of big data, the complexity of text, images, variety information, in addition to the size of the information, the cognitive computing came to help us in a little different direction, is to help us in the direction to make sense and getting signs for this complex data, which is, let's say, um, cognitive computing, for instance, communicate with us in natural language. That's why natural language processing is part of the cognitive computer. It's not programmed like we mentioned. Cognitive computing is, let's say, um, has to learn like we human learn how we train the computer with a lot of data until we get some confidence interval in the responses he is giving, and the answer which the cognitive computer is going to give us is, let's say, is not the numerical answer of the programmed computer, is let's say statistical answer with some confidence. The probability of this answer is close to what, to the right answer. Let's put it this way. This is in general the output from the cognitive computing. So mostly it simulates the way we as a human learn about our environment. We learn by sensor, by communicating with language, by reading, right? And we learn constantly. The same way the cognitive computer constantly can improve, more learning, more training, and give us more certain answer to certain question. So Watson, as an example of cognitive computer, was built first, let's say, as a proof of concept of the accumulated knowledge in this direction to something which is very attractive, like to win the game of Jeopardy against the best two player. And this was a very attractive presentation of the capability of what IBM was able to put together, given the available technology and the available methods, put all them together with one specific objective. So before continuing, I want to come back here to the graphical presentation of cognitive computing, and I would like someone of you to interpret for me this. What is this picture telling you about the cognitive computing? Anyone wants to take a try? Anyone, please? Can I ask someone? No one? No one wants to attempt? Don't worry, you never will be wrong, because as you understand, picture has, like art, many different meaning. But as you see here, they are the human brain and the computer brain, and they communicate. Let's see what Jonathan says. Oh, I miss it. Computer are getting more advanced and becoming self-aware. Jonathan, this is what you see in this picture. That means that they can, let's say, themselves give us answer. That's in the right direction. Okay, any other thoughts? Well, I want to hear more about this, but think about something which in the artificial intelligence, in science fiction, we have been hearing a lot that the computer can get, let's say, out of human control, and they can direct us. Of course, they are different opinion about this, and I would like to express only idea which I can support. And with in the stage, the sciences today, in the computer sciences today, we see only the cognitive computer as an augmentation of the human brain. It's not to substitute it. So is to help us in very difficult activity. One simple example we've been talking, and I see some of you have posted, is in healthcare and specifically in 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 precise diagnosis, oncology, cancer diagnosis. Why? Any doctor today to put a precise diagnosis, they are for this specific case, beside the analysis he may have for the patient, all the advanced analysis, they are at least 100,000 related article. And you understand that human brain is not possible. There is not physical time for a doctor to read all these related articles to the case of the patient. So that's why we are talking about, in this case, a computer like Watson is augmentation of the human capability. Watson can read this 100,000 article in no time and give a suggestion to the doctor. At the end of the day, the decision is human, at least in this field. So this is just trying to clarify some stuff I see in the discussion, and I feel they have to be clarified a little better. So, talking about the cognitive computing, we are talking about that the problem which will be solved is not a numerical problem, is the computer, let's say, produce hypothesis, look for evidence, and recommend with certain interval of confidence what supporting evidence, let's say, weight the supporting evidence and make the conclusion with certain confidence level. This is the summary of the cognitive computing. And as we were talking about, as mentioned previously, Watson is an example compiling the most important step in giving the answer we just delineated. It's very important that inference is the most important step of this. And you understand, if I'm telling you, if I'm asking you why this computer Watson was possible to build in 2011, obviously many of you are going to tell me yes, because at this point we had already technology like Hadoop, not expensive to store huge amount of data, and we had powerful search mechanism to search this data. And what comes to mind is, well, we load, let's say, a cluster of server, Hadoop cluster, with all Wikipedia information, with all available, let's say, related to this game, which is Jeopardy. We load this in this supercomputer, and with very, let's say, sophisticated search mechanism, we can find the answer. And for what we've been doing during these 2 weeks, all of you understand that this is not possible. First of all, even though the technology is cheaper, there is no sustainable to plot all this information physically in whatever number of Hadoop cluster you will find. Moreover, for the type of question which is this game, you understand, even if all the information, let's hypothetically suppose, yes, all the information is there and you can search it with the Google search or whatever advanced search mechanism. You're not going to find the answer explicitly. You have to process every time everything there, look for evidence, weigh this evidence, and infer. The most important is you will have to infer the answer. The answer is not going to be there. So you understand why let's say, design like Watson rely on all accumulated knowledge in machine learning, in statistical analysis, in artificial intelligence, because the inference actually algorithm are the base of the artificial intelligence. So in many ways we can say this very close to the way we as a human make conclusion. And I have separated one of the characteristics specifically here down, which is very important. You should understand one of the important characteristics of cognitive computer is adapt and learn. What that means? Uh, that means, first, when producer like IBM or other people are working in different cognitive computer like now right now. There are many company working in different direction. Just they are around 2-3 steps behind IBM at this point, but they are catching very fast. So we will see how things are developing in the next few years. This is the future. When we talk about adapt and learn, here is something very interesting. Uh, IBM did Watson cognitive computer for one specific application, which was Jeopardy game, in which there are certain rules and where the player has to answer in 3 seconds, and to win the game, he must answer around 85% of the question correctly. That's are in general. They are more specific rule, but this is just to in general describe the game. And they built a cognitive computer uh, with this in mind, the solution of this problem, and put as a base of this computer what is named the technology of deep Q&A. Deep Q&A is, let's say, when IBM started working on this project, they didn't do everything from scratch. They used whatever was advanced in different universities in this direction. So the deep Q&A was already developed. So they took and they perfected this. Hadoop existed let's say, as a storage for search for big data. So they took everything together and put it for certain purposes, which they used some very brilliant idea and were able to show a computer powerful enough to win to the best two Jeopardy player. So one of the characteristics of this computer, besides that is built for certain application, they load this computer with document related to the topic of Jeopardy. They didn't get all available article information of all library, encyclopedia, Wikipedia, whatever library. They didn't do that. They loaded only the information related with the game. And after they proved this concept, all the development of this in this direction are to build a specific computer for certain application. And moreover, they put this in the cloud, which is much less expensive. Let's put, if the proof of concept, the Watson for Jeopardy, the cost of this computer, it costs much more to IBM. But if you just take the bare hardware, it's around 3 million. Of course, the research and all development to IBM costs much more. But you understand that today businesses, who is capable to pay this price to have this computer, is meaningless, because only very few businesses can afford this price. So the development continued in the direction which makes sense to the businesses. The computer capability was deployed as a service in the cloud, and each service pertain to different application. And these different application can be healthcare, can be language, can be personality inside, can be any of the, let's say, of the services you can observe in Bluemix, for example. They are much more. We have access to this part of Bluemix, and for us, from educational point of view, these are very meaningful applications. We can start exploring them. So what I want to point out that all this is deployed in the cloud, is much less expensive. You can use only in the realm you are interested. It is a business. You have the bare, let's say, the bare application. But on top of this, you have to build and train this application for the purposes of your business. And there is a lot of, let's say, free code in GitHub. You can get almost anything already is free if you are ready to build your application in Watson. And build your application means that you're going to use this last very important characteristic, which is adapt and learn. What that means, you are going to fit this service with the knowledge you are interested that the application acquire, and it will be adapting constantly, learning more and more and more, and getting more precise in the answer you are looking for your business. So, any question, any comment up to here? I don't think I have to pay attention to these two slides are in one of the presentation previously in the previous presentation, and they very clearly present why Watson is not simple search of keywords. The same keyword search you do in Google search, you do keyword search and it appear, let's say, 100 reference, and you have to use inference and apply other knowledge in order to get your answer. If you do simple keyword search, here very clearly is presented this very nice example about the celebration of the 400th anniversary of the explorer, which arrived in India. And with simple keyword search, the system will find that as an evidence, the passage which is in May, Gary arrived in India after he celebrated anniversary in Portugal. And this has nothing to do with the initial question. The initial question, the answer is Vasco da Gama. And doing key search, the system was not able to find the right answer. What is the deep Q&A is the mechanism which permits searching in deep in the different documentation using different reasoning in time, statistical, geospatial. The system is able to get the right answer, which is that Vasco da Gama is the one who in May 27 of 1489 arrived in Kapat Beach, which is in India. But you see, the answer is not found by simple keyword search. So I like very much these two slides. They are in another presentation. You can look to them. You can also look to the different, let's say, video posted in the classroom. My main interest in the remaining of this week and the next week is to understand, explore what is in Bluemix as a services, as a Watson services, and make sense in you. You have different interests in the class. Some of you are interested in the media and entertainment, other in government, other in healthcare. Just try to understand these Watson services in Bluemix. You can explore them we have free access to them. And the most important is what potential application you see in any of this area. So my expectation, let me share another screen here, is going to be my screen, but my screen is not this. I want this screen. Well, this is Alex the Kid. I'm going to send it to you shortly. Now, this is Bluemix, the catalog of Bluemix. I guess uh, I want to believe most of you already were here. Not clear for me for the discussion because I don't see evidence except few that you were here in Watson services. I'm in Watson right now, and you have explored any of these tone analyzer or personality design or whatever. I suggested some, but you are free to explore any of them. And there is nothing difficult. You just go to your Bluemix account, to the catalog, you go to the services Watson, and just let's say tone analyzer was one of the suggested. You see that the first 1,000 API are free. So instead to making your life difficult, I didn't put this as an individual assignment to submit report. We are doing this in the classroom and exchanging experience, but the purpose is to get, let's say, to get inside what is this about and what is the purpose it can serve in your future job, career, whatever. So the easier way is you go to view documentation. And when you go to the documentation, there is plenty of information which you can read. And there is demo. Go to the demo and you will see the demo are with already, let's say, uploaded text. You can just say analyze, and Watson is going to give you the answer. The answer for the output is this. I'm not going to spend time to tell you what is this about. Just I would like that everyone explore at least two of the services and try to make sense where you would use this. For instance, here is example about email, about corporate announcement. Explore this and you can put your own test and also analyze it. So for each of the let's say services in the catalog, for each of the services in the catalog, you can proceed the same way. Of course, it's much better if you add the service and you do something more serious. I don't know how much time you have allotted. My suggestion is try to participate very actively in this discussion, and the most important, explore in your own time few of these services and try to share in the class where you think this can be useful related with the work you are doing with or with some future job you are planning to do. Okay, I'm going to stop sharing. Any question up to here? Any question with Bluemix? I don't see anything in the chat, so I can stop sharing. I don't think there is. If you still need to go, let's say, like a walkthrough because you don't know where to find the thing in Bluemix, there is a walkthrough video in the classroom. Where is the? Let me share. again my screen, but now my screen is going to be the classroom. When you go to the classroom, in the content, there is a Bluemix setup instructions, and here you have the tour to Bluemix. Just if you feel that your navigation in Bluemix is a little difficult, it's understandable because Bluemix is packed with services. So take this tour is very let's say a little time to spend on this, and you are going to save time in long run. So whatever is in the classroom, I can tell you, try to get organized and explore as much as you can. Okay. So this is all I have regarding the my expectation regarding Bluemix. Now we proceed to what is in memory analytic DashDB. The purposes are clearly delineated in the classroom. There is plenty of material to learn. I have summarized several important points. I will be posting the PowerPoint presentation. I want to point to three important points. What is the business need of in-memory computing? And when we talk about in-memory computing, don't think just like everything is in memory. You understand that with big data, what most businesses want to get, let's say, to get competitive advantage related to the other businesses in the field is to get faster and better insight of the data, and faster and better, and of course with a reasonable price. In memory analytic is an answer, is one of the answer to this. In memory analytic, is not just that all the data is in memory. This is complex technology which IBM deployed what is DashDB in Bluemix, and we have free access to DashDB to do analytic with the deployed analytical tool there. Just I want to point that this new technology makes the normal price of $5,000 for gigabyte in memory to less than a penny. How? They use very advanced patented technology which are different. This is a combination named BLU technology which IBM uses for DashDB, and it has to do with prefetching the information in buffer. So the information is already ready. If you are going to, for instance, to analyze coming Twitter data, which is stream of real-time data, you understand that are the type of application which really business need to process in almost real time to get competitive advantage. So there is buffering, prefetching, there is data skipping if the data is not relevant to the analysis, and you name it, a lot of interesting technology. I would say one of the most important part is the massive parallel processing, which is building, let's say, these are networked cluster which work in parallel, and the memory is organized in wide columnar store. This is, let's say, the last DOSIQ technology. You understand that in big data, if you organize data in the normal table of row, when you have to, let's say, to access a million of data row, this is going to take time. So the new technology, the columnar technology, you look for big data, let's say for 2 attributes. You're going to access with 2 columns all the rows simultaneously. So this is the I very simplified the explanation of this. There is a lot of material posted in the classroom. You can review that if you are interested in the technology. We are more interested in the analytical capability. The good thing of this technology that it scales linearly. Very few technology actually scale linearly. Hadoop doesn't scale linearly. Okay, so this is very nice technology. For instance, you add 4 servers, your time is divided in 4. So very nice linear scaling. Our main interest is here, is summarized in this slide. Besides this advanced technology, which is going to permit you to, let's say, to do in-memory analytic of data like Twitter data, the Twitter data you are going to use for this second assignment. There are several predictive algorithms built in, which is linear regression, association analysis, decision tree, clustering, and you will be using this algorithm in R to extract, let's say, insight for Twitter data. This is mostly the assignment 2 coming up. The other important thing, so again, here in this slide is our main interest in this class. All other is interesting, but this most technology is good as a data analyst. You are prepared in the technology, but the most important thing is the modeling part. And of course, very nice external application with other Bluemix application. One of them is the Insight for Twitter we are going to use. So this is the general part I have for today, and I'm planning to give the word to Elena, which is going to try to save you time. In the classroom, we have something which is named walkthrough to DashDB, and you have instructions step by step. But she's going to do additional walkthrough now, let's say in real time, so you can ask questions also. And just to speed up your grasp of these two, so you can concentrate in the analysis. And with no more, I'm giving the ball to Elena. Elena, are you ready? Where you are? Oh, here.
Yes, I'm here. Yes.
Okay, the ball is yours.
Okay, so I have to select
Share.
Yep. Trying to share my screen. All right. So what you guys need to do here to get started, you would need to go into the catalog, right? And when you're in the catalog, on the left panel, you want to scroll down to the services section, and you want to select data and analytics, right? And what you're going to do is you'll need to add 2 applications. The first application, you'll find it, it's called Twitter data, right? It's in here. Insight for Twitter, sorry. Right? So to do that, you would just click on this, right? And here you're going to hit create. I'm not going to do that because I already added this to my dashboard. Very important, you want to add this only once. We're not adding 2 copies of the same application to the dashboard, right? We're adding it only once. So now, since I already added it, let me go back, right? And to go back, I just click here. Now, speaking of getting back, use menus, right? Forget that you have a back button on the browser. It no longer exists, all right? Because if you use the back button in a browser, the results could be unpredictable, so just don't do it. Now here, you're going to click on Data and Analytics, and you're going to add another application, and you want this one. You want DashDB for Analytics. There are 2 similar shortcuts, so make sure you get the one for Analytics. Alright? And then you're going to click on Create, I think. Yes, Create. And that will add an application to your dashboard, right? So once you've done that, this is how to return to your dashboard. You're going to click over here. This is the main menu, right? And then you're going to find dashboards. See this? It's going to take it to a dashboard, but the dashboard has several sections. One section is the application. It's on the top, but we're not interested in that. We need to scroll down to the services, right? And you're going to find your service that's called DashDB, right? That's it. And as you may notice here, you may toggle between, there is a way to toggle between the list view and tile view, but right now it's showing me this as a list. Alright, so let me find it back. Here is my DashDB, and I'm gonna go ahead and I think I can just click to launch it. Yep. So now what it's gonna do, it's gonna open the service launch page, and I'm going to click open. Right, and I'm going to show you something here very important. Notice there are several tabs in here. This is a very important tab right here, Connect, and I'll show you why. So when you log in, go to the Connect tab and take this and write this down, right? So you consider taking a TextPad application or something like that, or a Notepad, and copy and paste this. And I'll show you why later. But you want to write down this user ID and the password. All right? So now there are multiple ways to get data. You can just load the spreadsheet from your desktop, right? Or you can, or what we're gonna do for this assignment, we're going to read the data from the Twitter. So how do we do that? We click on load, right? And you want to select the Twitter data. So what's going to happen behind the scene is that your DashDB application will call the service, the Twitter Insight service that we added to the dashboard a few minutes ago, right? So here I want to say use an existing Twitter service because I already added one, right? So now I'm going to, so that's my first step. I'm all set. I'm going to click next. And for some reason, this is one relatively new feature. I'm getting this pop-up, but you may just ignore. Now, click next. It's going to take some time. It's going to take its time. Now we are getting back to this. Now we're on the second tab. It's called search. So what we need to do here is we need to enter the search criteria, the topic of interest. Like, for example, I want to search something about the Giant store. I'm just giving an example. I just entered my criteria, put a hashtag, and typed in the criteria. Now I'm going to get the tweet count. And the reason I'm doing it is that because I want to check how much data it's returning, right? Because if it's returning way too much data, I would have to click on a search help, and I would have to find a way to narrow down my criteria or something like that. Because if it was returning hundreds, thousands of tweets, well, we have to keep in mind that the time it takes to load the data depends on our internet connection speed. So, but it's not bad. And now what I have to do is I'm going to hit next if I'm satisfied with this tweet count. All right, something very important, very important. If you have somebody who shares the network with you, right? And if your internet connection speed is below 50-50, you need at least 50-50. If it's below, make sure that nobody is streaming videos at the same time while you're trying to load this data. Plan your time accordingly, because this could take some bandwidth. Now, what's going to happen here is the application is going to create these tables for me, right? 1, 2, 3, 4, 5, 6, 7 tables. But naming convention, I want to add the prefix, right? See, this is a table name suffix. I need to add a prefix. And let me see, let me call it giant, right? So here, this is a table name that is going to be. I'm creating a set of brand new tables. Alternatively, I had an option to append the data to already existing tables, but I'm going to create new ones now. Giant, right? So what that word means depends on the context. Well, if you live in DC area, Giant is the name of the grocery store, but let's see what's going to happen. Right now, I'm going to click next, right? So what it's doing right now, it's loading data. So you see the bar moving and the time remaining. Very important, do not hit the back button on your browser and let it load. And then pay attention over here. It's telling you how much space you have, right? Because you have a space quota, and once you exceed the quota, you would probably need to go back and delete some of your tables that you're no longer using. Because there is a space limit, right, on our accounts. So right now it looks like it's finished. This is the check mark, means it's finished. So now I'm going to click on next. And here, very important, when you get to this page, take a screenshot, because there is no way that I know of to get back to this page. I have not been able to figure out a way. If you show me how, I'll appreciate it. But what you'll need to do in the assignment is, in the graded part of the assignment, you'll need to explain what you see here. So basically, this chart here, it's telling me the number of tweets over time. So it could tell me approximately what time of the year people discuss my topic the most, right? And there are different types of posts. There is an author and there is a follower. Follower is basically a response to existing posts. And here is my location, the hashtags. Those are the related hashtags. Now, notice that giant lowercase is not the same as giant uppercase. It's treated as a different hashtag, right? So this is case sensitive. And if you also remember way back from data mining course, missing values, that's an example here, right? Some posters, they don't have a location, no, they don't have information on location specified. And same thing here. Well, oh, right here, see, that's not available. Sentiment, positive or negative, but most of the post is unavailable, right? So now what you want to do is take a screenshot. Now there is another tab over here, the data tab, and here you can just preview the tables that you have loaded. Oh, and by the way, to close this pop-up, take a look. I hover over it and I click on clear. Alright, so here it's giving me an option to check it's just to verify that my tables have been loaded, my data was loaded, right? So I can choose a different table and just take a look here, right? That's one way. So now I'm done. Let's just assume that I saved all the screenshots. I'm done. What else you can do is, here is a tables page, right? So that's another way to check your tables here. Now, that's called a schema. This is your username, right? So everyone in this class is going to have a unique username. And if you may remember, I wrote something down. This is my username. And I'll show you where you need to use this password. Right? I'll show you. Now, here, so this is a schema, right? If you may have taken a database course, you may remember every user ID is a schema. So when I create a table, it's going to be sitting in my schema. Only I can access it. For instance, Linish won't be able to access it unless I explicitly grant a permission to his username. So now what I can do here, I can select my table, right? Here it is, giant tweets, that's something that I loaded. And here it's basically showing me the structure. It's not showing me the data, it's showing me the structure, right? To browse the data, I can click on Data tab. But the problem is, suppose that I want to select the data that meets a specific criteria, right? If that's the case, I would have to use my query stub, run SQL, right? And some of you, if you may need to brush up on your SQL skills, we have some resources in the classroom, right? And let me know if you may need a WebEx session or something like that, a help session on SQL. I'll be more than happy to do that, right? Now, basically, to run the queries, that's what you can do. You go here, run SQL, and you go in to type the query command. So it's taking a little bit of time to load, but this is an interface where you run the SQL. Here it's giving me some sample queries. Let's look at the sample. So basically there is a sample user, there is a public user that's accessible to everyone, and this is one of the tables on that user account. So select star from. You have a select clause, and then you specify what to select, which columns you want to select from the table. Star is a wildcard. It means that I want to select everything from this table right here. But because it's not one of the tables that I created, it's a table that was there for me, I had to prefix the table name with the username. That's why you see this here, right? So now I have several options here. I can put my mouse here and run the selected. Bang, here it is, right? It just ran one single statement. And to see the results, you're going to click here. It's going to show you what the query returned, right? So here's my data. And you can also click on the log. The log basically saying that the query ran successfully. If you receive an error message, the log is your friend, right? You want to look at the log to see what happened. And see here, you can go to the data here as well. And what you could do is you can export this to the CSV file, or you could show hide certain columns. Like suppose that I have too many columns returned and just want to hide. Or you can filter it. You can define a filter, but the problem is we want our work to be reproducible, right? So if I define filter right here, right, if I run my query again, I would have to define the filter again, right, which is not effective use of time. What you want to do is you want to add the where clause to the query, right? So the query has select clause, and after select you specify the columns that you want to display. It has a from clause where you specify the table name. Where clause specifies the condition. In this case, they want the quantity above $9,000, right? And order by is to sort the results. And by default, the data will be sorted ascending by the columns that you specify, but you want to do it descending, right? That's what they're trying to do in here. So that's basically some existing queries, but when you write your own queries, what you want to do is, perhaps you would find it helpful to go back to the tables, and you want to sort of like create a cheat sheet for yourself with a list of column names in each table. So that way you could just copy paste, right? Because when you just type it, there is a high chance of making a typo. Now, there is something very important I want to tell you. And each semester, at least one person does it, but I need to tell you that never, ever, never type SQL code in Microsoft Word or in on a rich text format documents. Never do this, because the special characters get introduced, and those characters are not recognizable by SQL, and it makes the code fail, and it's very, very hard to fix. There have been times when I had to rewrite the SQL script from scratch. And one example of the character is a Microsoft Word quote. It just breaks the code, and it's very hard. You really have to, sometimes you have to rewrite it from scratch. So I've been repeating it every semester, and at least one person does it, but, well. So here we are querying against the table, right? But what I also did, and you're going to find it in your walkthrough, I created a view, right? So if you go back to the tables, oops, right here, tables, you can also see that what I did was I created a view right here, and I call it UMEC sentiment. That's one of the views that I created for the walkthrough. Now notice what happened. When my tables were created, oops, I think I called it sentiment view, but take a look at this. This is a set of tables that got loaded, right? And the problem is, my data is in several tables, right? See this? I have a little bit of data in separate tables. The problem is, when I analyze this in R, I would have to do a join, right? I would have to somehow in R join the multiple data frames. So as an analyst, I would need to worry how my data is stored, right? So the view enables the data independence. So what I could do is I created a view, and the code to create a view is in walkthrough. I created a view and I called it a sentiment. And what the view does, it's pulling the columns that I need. Behind the view, it is joining those tables, right? I'm joining the tables on a column, on a common columns, and I'm creating a view over here, right? So that way, when I get my data into R, I don't need to worry where my data is stored. Also, if somebody goes in to my account and adds another column to the table, it won't affect my R analysis, right? Because I created a view, and I'll try to do my best to pull data from the view, right? So that's one way to do it, and that's probably the best way to do it, to create a view. And the code to create a view is in a walkthrough. So basically, to create a view, the code is similar to the select statement, but you're gonna have another line, create view as, and then inside you're gonna have a select statement, right? So, but basically, see here, table's name, for some reason, it's not listed as a view, it's listed as a table, but, well, but you got the idea, I hope, right? I'm not sure what this is, it might be something new, but I did not create this. Okay, so now what we're gonna do is, we're gonna get to R. Look at this, analytics, R script, right? That's an R interface. Now, you have two options here. You can run your script in R interface, or you can launch the R Studio. So to get started, what you need to do is you click on import, right? Oops, sorry, I'm wrong. You're gonna click on a plus sign, create new script. Create new script. Right now, the pop-up is asking me to choose a table, right? And this is my username, right? Schema is a username. Here, those are the samples that I can access and play around with. But this is my username. And what I could do, for instance, I can scroll down, just perhaps I want to do this view. I click here, and here I'm going to get a list of columns, right? I can check or uncheck what I want to select, and I click on apply. Behind the scene, it's going to write the code for me, right? What it's doing, it's calling the library. It's a library to open a database connection. And if you're interested in a classroom, there is a link to documentation on this library in depth, right? So what it's doing in here, it's creating our data frame. This is a data frame name, and it's pulling the data from this view, right? It generated the code for me. That's what I did. I don't like this name. It's not descriptive, right? So what I did is, in a walkthrough, I just went ahead and I renamed this. You can rename it. See this? I can just rename it, right? So now, suppose that I wanted to load another table. To do that, I would just do this, add data frame, right? And I would pick another table right here. And, well, just an example. I'm just going to do an example. Apply, right? Here it is, but again, it's given its own name. So if we don't like it, we can always change the name. I like to change it. Here we go. Now, suppose that I'm satisfied with the script as is. What I need to do is I need to save it. Save. And where is it going to save it? It's going to save it on the server, right? So let's just call it demo. Demo.r. Save was successful. So I saved it, right? And how do I know? I would need to scroll down, and at the bottom, it shows me my script that I saved. I have a yomuc script R. This is a script for the walkthrough, and this is a script that I just created, right? So very important, make sure that you save it. Now we're going to launch the RStudio. Make sure that you pay attention to the supported browsers. I believe Internet Explorer is not supported, but Firefox probably is. Yep. So when you click on here, it's going to launch a new tab. More likely, when you do it for the first time, it's going to prompt you for the username and password. It did not do it for me right now because my session may have been cached. But when you log in for the first time, right, when you click on the Launch RStudio, you're going to get a login screen, and you'll need to enter your username and password. The password that you enter is the one that I just wrote down, right? So here is your user ID, and this is the password. Now, this is called a two-factor authentication. You need to be logged into Bluemix first, and then this is the credentials to log into the RStudio from DashDB, right? This is why you need these credentials. This is for the RStudio, right? So I reopened it, and what it's trying to do, it's trying to restore my last session. So here is a script that I opened during the last session, right? So I had this nice script here. Here is the history tab. It's going to run. It's going to show me when it loads. It's going to show me the commands that I ran. Another important thing to keep in mind: the R version that is installed here is 3.2 something, but it's not 3.32 that you have been using for the last assignment. It's because this is a cloud application. And depending on the version determines what packages you may use, right? So if I'm not sure what the version is, you run this command r.version, right? And you want to check what version you're working with, right? And it's a little slow, but it's a little slow at the moment because it's still trying to restore the last session, but the output is going to show me, here it is. That's a version that installed 3.2.1. So, warning, some packages that you were able to use in the last homework assignment might not be available here, right? But you'll still be able to do the text mining, and to do some of the text mining analysis that you were doing last week, you would need to install the packages. whatever you see here, system library, this was available, right? This was available when I launched it for the first time. But everything at the top here was not. Everything in the top section here was not. So what I had to do is I had to install the TM package, but when I did that, I had to use the argument dependencies equals true. And because this package depends on NPL, and I believe it also depends on a SLAM, right? So what I want it to happen is I want the R to install the rest of the packages that needs to be installed for me, right? So you would need to install the TM. That package is available, and everything that you see I used here is available, right? So yeah, documenter matrices, they work. Word cloud should work. Clustering depending on what implementation you're using. Now here, if you look at this right here, files, here is where you see the scripts that you saved. Notice that demo.r is a script that I just saved. Something very important to keep in mind. What I'm doing right now, I'm clicking here, I'm opening the script. When I make changes in here, right? Let's see, I'm gonna make a change in here, and I'm going to put this command right here. I made this change, right? But I did not save it. What's gonna happen right now? If I go back here, the change is not here, right? I have my script, I have the script, demo.r, open in this interface right here, and I have it open in RStudio at the same time. Whenever I make change, I did not save it, right? So now let me see if I save it. Let's see what happens. I go back. It's not here automatically. It's not. What I need to do is I need to refresh. I have to refresh, right? And then I'll have to reopen it. But basically, it's one. See, I have to click on it again. One of you pointed it out that the script was working in R but was not working at the R interface. It's because when you make change, you need to save it. It's number one. Number two, you have to reload this, you have to refresh, and you have to reopen the script. You have to click on it to open again, right? You just need to do that. And similar here, if I make change, I have to save it and then reload here. Now, what also happens here, I installed the packages, right? I installed the packages, user packages. When you install the first one, you might be prompted about creating the directory, something like that, but just hit yes if you get it. Now, take a look at this. Here are my packages, right? Where they get installed, I'll show you that. You go to Files, and you go to R, and you click here, right? 3.2, and here are the packages that are installed, right? So everything here, word cloud, you'll be able to do this, and TM, you can do this, right? And the reason I'm bringing it up, because you can take the actual tweets and you can run text mining on the tweets, right? So I can go ahead and I can run this script. The script is in a walkthrough, right? So here it's opening the database connection. It's reading the data from data frames into the tables, right? And notice that my work is reproducible because I have a script. So now I'm doing a demo to you and I can just run my script, right? I don't have to sit down and type here. Here, what I'm doing is that this is going to do the count, right? So I'm going to say this is going against the sentiment view, right? And it's going to do the count by gender, how many males, females I have, right? Remember table command. It's just going to do the frequency table. And here, I want to do the count by message action within gender. right? So I can do like this. I can do the tables like this. And also, do you remember that if you do the pie chart, they take this table as an input, right? They take this table as an input. So what I could do is, remember you can use the up and down arrows to rerun the command that you ran recently. So what I could do is this. I can put it as an input, and I can have my nice pie chart. Here it is, right? So this interface is similar to RStudio that you used last week, right? Now here, I'm doing a little bit of the sort of stick time series analysis, and if you're interested in a classroom RStudio resources by topic, there is a document on how to do the dates, on how to process dates. So here, this is a message, time when the message was posted, and I'm trying to pull the date part of it. I'm trying to pull the date, right? So I'm converting it to the date. And here, I'm just trying to get the number of posts per month. This is going to pull the months and the year. This is just the format code, and you can look at the documentation. You run the help command to see those codes, right? Here, this is a pie chart that I showed you, but this one is going to show the breakdown by the polarity. And you can also do the plots. You can do the plots of number of posts over time. Well, I didn't sort it, but for you, if you're interested, you can do the sorting and you can do a nice plot. But here, what also I'm doing is that here I'm trying to see on what day of the month, on what day rather, we had the maximum number of plots, right? I want to know when we had the maximum number of, maximum number of posts, right? So this is a date. On that day, we had 103 posts, right? And I can do my plots here, right? And here, this is a key part. If you want to do the text mining, and I added it this semester because some people asked me for the last semester. Tweets table, tweets data frame. See this? If I go in here, tweets over here, tweets data frame has a field called message body, right? Message body. What we could do is we could treat each message as if it's a document. Remember, in the last assignment, you were analyzing the set of the document. So what you need to do is you have to convert this field to the vector source. You have to create the vector source, and then you use the vcorpus. So here are the steps to do this. And this is a command, another command, right? This is a command to preview. So let's run this. Let's see what happens. Docs. And this is a preview. See this? So that's showing me the content. There are 423. It created a corpus of 423 documents. Right? This is what I did. And now I can do similar analysis to what you were doing in assignment 1, right? But before I do this, this is very important. You need to install the TM package, and you need to load it into memory. The package is unavailable until it's loaded in memory. And to do this, you want to make sure your code is reproducible. So you need to write a command, require, and then put the package name, right? Or another option, if you check it, if you physically check the checkbox, then you want to write down the command that it runs for you, right? Like for instance, look at this. I'm going to check this checkbox. It displays the command. You want to add this to your script, because next time you don't want to worry about checking these checkboxes, right? Now here, well, I can just run similar analysis to what I was doing, what you were doing rather, right? And here I'm removing the numbers. So basically, I'm doing this. I can do the same thing, almost the same thing that you were doing on the last assignment, but some packages may take their time to install. So you want to make sure you have a good internet connection and that nobody is trying to watch cartoons. I mean, not trying to stream cartoons or videos at the same time, right? Especially if your internet connection speed is not at least 50-50 or 75-75. Uh, Here the snowball, see, do you remember the stamen? Yep. So let's see, it's already loaded for me. I see why, because it saved the work that I did in the last session, so that's nice. So I can run this, and I can keep on running. Same interface, right? So I'm trying to get my frequency counts, and I'm trying to build my matrix. Exactly same, right? Something similar. So this is one of the options for you to do. You can also do the association rules, but if you do that, remember that the variable types have to be categorical. So you would need to convert the character variables to the factor, right? Because if you note here, well, you would need to look at the str command in order to see which data type it is, right? In order to see the data type, you would need to run the str command, or you can also look up at this tab. See this message option, post, right? See this, it's a character. But if you want to use this field as part of your association rules, you would need to convert it to the factor, right? As factor function. And also, if you have a numeric field, you need to do the binning, because association rules method does not take the continuous numbers. All variables have to be either binary or the categorical. So there is some data pre-processing that you would need to do. And you can do decision trees, you can do clustering, but I would like to see you guys get more creative and do not limit the analysis to example posted in the classroom. Go beyond, right? You want to put your, so to speak, personality in your project. This is you. It's something. It's your work. It's something unique that has your name on it, right? It's not Yelena's example. It's not something that you saw in the last WebEx, but it's yours, right? So, like for instance, here, how can you go beyond? You could think about removing non-English characters, something like that, right? Or there could be another text mining method that I have not seen, I have not done, and you may read about it, you want to apply it, you're more than welcome to. Right? So go ahead and do more readings, check out the resources in the classroom, and use examples from the readings, but apply them to your data. But you not necessarily have to do exactly the same code that's in a walkthrough. The purpose of the walkthrough is to help you get started, but this is your paper and this is your analysis, your study, right? So, yeah, and remember, anytime you make change, you want to save it, right? Uh, if for some reason, you are unable to open RStudio, well, things happen. As a backup plan, you can always run your code here, right? You can always run the script here. If you do that, well, there are some limitations. You cannot install package while you're here. You have to be in RStudio. But to run the code here, you have to click submit, and it's going to run everything, the whole file. Then there are two more tabs. The console output tab is going to show the output that I would see in the console over here. The plots tab is going to show me what I'll see in this panel, in the plots panel, right? And this is nice. It remembers the work that I did in the previous session. so which is good. See, I was playing around with UMUC Twitter data, and on the title page of the assignment, you see the dendrogram screenshot, and to make it look nice, it's a matter of playing with the input parameters. So if you're using the dendrogram here, something to keep in mind that the dendrograms don't really work well when you have a large number of terms. So you would need to really play with the input parameters. So see, you can do visualizations like this. And I think you have an example. You do have some readings in the classroom in the RStudio resources by topic, and there's some examples that show you how to do the network of terms, right? So this is like a sort of like a neural network example, right? You can do this. This is just an option, and you can do the time series analysis, right? Or you could try to do, if you're interested, you could try to predict how many posts are going to happen tomorrow. I believe it's ARIMA models, and you can find, I'm going to check if the page on RStudio resources by topic, if it has time series analysis. I'm going to check if there's some resources there. But there are some options for you to explore, right? So let's see what questions we may have. I realize that it's a lot, but I want to see questions. And sometimes when we get an error message, it could be hard to reproduce, so we may have to set up the screen share session, right? It's highly possible. But most of the issues that I have seen last semester is that some students try to add the service multiple times, which is not good, because when you add the service a second time, it's equivalent to creating a second database user. So what you create as a first user not going to be visible to the second user. So then, as a result, they were reporting an error, not seeing the tables. They say, hey, Yelena, yesterday I created 5 tables. Where did they go? Well, how many copies of DashDB do you have on your dashboard? Make sure that you have only one, right? Because if you have more than one, you're not sure which one you used when you created the tables, right? So it's a lot of considerations here, right? If I make change to the script, I have to save it. Otherwise, I cannot access it here. See, it finished running, console output, and it's going to show me exactly what it was showing in RStudio console panel, plots. I would have to click here, and it will open the PDF file. It's all my visualizations. For some reason, it's showing only 2, because the script that I just ran, that's what it just produced. Right? I did not run the script with more than 2, I think. I just ran the small one. All right? So, and also, if you're getting an error message, they're going to be displayed in the console output. So you want to make sure to get a full error message and try to see if the script that you're running is the latest, and remember that R is case sensitive. A lot of considerations here, right? So just, yeah. I'm sure that you have questions as you start working on it, but yeah. So now you remember where to get your credentials for RStudio? It's right here, right? Connect this page, right? So you want to write this down. And another reason you would need this, if you want to, well, you probably won't be able to unless I set it up for you. To access it in general, it's possible to load the DashDB data in Watson Analytics. Yes, it's possible to load DashDB data in Watson Analytics. And you can also analyze the data in other applications such as Tableau and more, right? So there's a lot what you can do. Yeah. But I'm surprised we don't have questions.
Yelena, they haven't started. They
Okay.
haven't started working on this assignment. Like we had for 3 weeks the first assignment, and
Mhm.
I started just 3 days before. So even the most dedicated people are sitting here, they haven't started, so you cannot expect more questions
Oh,
now.
yeah.
The question will be later in the classroom.
But yeah, but there is something else to keep in mind. Oh, what is it, Peter? Peter asked something. Oh,
I,
Peter, I think I see what you're trying to ask. There are two services. Well, let me see. No, 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 no. You don't need to pay $50 per. Oh wait, it says you need to pay $50 per month. Don't worry, it's not gonna charge you $50 per month. Don't worry. You know why? Do not enter your credit card. You'll be good. Do not enter your credit card information. Don't worry about it. But thank you so much, Peter, for bringing it up. So, yeah, what Peter is trying to say is that if I go, yeah, to the dashboard, yeah, here is my dash, yeah. Yeah, this is a very good question because at some point I was surprised. Bloomix was telling me that I owe $1,000. It's because I added the service that I was trying to play with a service that would have been expensive if I put my credit card. But I was smart enough, I did not. So never do that. Oops.
may I say, if you let me show the screen.
Sure.
This is very important. I'm glad that this question come. I totally forgot to pay, let me grab the ball
Yeah, go
and
ahead, go ahead. I'm gonna stop
where,
sharing.
yeah,
Mhm.
well,
Mhm.
where you
I stopped
are?
sharing.
Yeah, you stop sharing. Okay,
Yep.
I'm here. Okay. I'm glad who brought this question. I didn't realize, but excellent. This is what I missed it previous time and now. And let me share my screen. Okay, my screen, the one I want to share is not this. It's not this. Wow, where it is. Okay. DashDB. I'm here in DashDB in Bluemix. When you go here, you will see the pricing plan of the service. We are in the entry level, which is not charged for up to 1 GB of data storage. This is the service as academic account we have. Okay, so you won't be charged. Now, if you by accident make a mistake and here you add your credit card, let me tell you, no one can save you because everything here works automatically. So remember, we are in academic account. We have some limitation in the use of the services. This is understandable because these are actually very expensive services. So what we are giving for free is totally wonderful. Just do not make a mistake to put your credit card because the day you put your credit card, you are not anymore academic user. Okay, please keep this in mind. I think I'm going to put this in red in the announcement of the classroom. So nothing is going to happen wrong. Just do not put credit card. Any other question? And you can see the pricing plan for any. We are in the entry level, not charge for up to 1 GB of data storage. Okay?
Oh, yeah. If you remember, guys, at the top, it was
Yeah.
showing how much free space I have left. This is where 1 GB comes from.
Yes.
Here.
Mm-hmm. Yeah.
It shows how much you have left when you're in DashDB, but Sometimes when you load the tweets, you want to check the count because sometimes the number of tweets returned exceeds the available space that you have. So that's why sometimes you're gonna see it would say it's stuck. The progress bar is stuck and it does not continue loading. It's because you might be exceeding your space quota. That's possible reason.
So don't get upset with this, because if you see the prices here, because this is really expensive. This is totally new technology. Streaming Twitter data or whatever other data is really expensive. You can see the prices. So what we are getting for free, just to understand how this technology can serve your purposes and to do a project for the university course, is wonderful. Just compare the prices and what we are getting for free. The only thing keep in mind, do not put credit card. I don't know how to stress this more and more. Yeah, other question.
And another one, maybe not as dangerous, but not to type the SQL code in a Microsoft Word. I mean,
Well, this is pain of other magnitude.
well, yeah,
It's pain of other magnitude.
yeah,
Yeah.
yeah, and it's a big pain. And well, I have DBST degree, so in DBST it's a huge pain where you do SQL a lot. But here we do SQL too, so it's a real pain. When you type your code in Word, that's it. Forget about it. Yeah.
Any other question, guys? No? Well, if no more question, we will be posting the recording and start working. As we have mentioned it, course is intense, like any of the data analytic courses, but this is really well-packed course. There is no time to get a rest between assignment and assignment. Really, no time for rest. It's 12 week all the time, something. Okay?
I have a question.
Yes.
This is Tracy Carr.
Yes.
So the DashDB seems to be to get the data in, but it seems like most of assignment 2 is still focused in R. Is that right? Even though it's kind of presented as DashDB?
Yeah, DashDB is the technology for in-memory analytics. This is a complex tool which has, I present, what you are asking is right in this still, right in this slide. I'm showing, right? I'm showing this slide right now. Yes, DashDB is the whole service, which is the database, but it has embedded predictive modeling algorithm like linear regression, association analysis, decision tree, and you have to run them in R. So there is no simple thing. Of course, you can look to DashDB as the database, but it's the whole thing, because you cannot isolate R from DashDB in the screen Elena was showing you. I don't know if I answered. Did I answer the question? Yeah, DashDB itself you could look as a database.
Right. So it seems like,
but without the R deployed in the way it is deployed as a service in the Bluemix, you cannot do anything.
Which is kind of under the cover and unseen to us.
This is what is service. And this is, I'm glad you are asking, Tracy, this question, because you have to realize here that we are exposed to totally new way of using the technology, not just because it's in the cloud, but because it's as a service. Service is not just an application, it's just not the R studio. Service is the whole thing which has embedded the database, the tool, and the connection to other external services. You can find this only in an environment like this. Bluemix is not the only environment. This is the one in which we are working. You can do very similar thing in the Microsoft Azure. Very similar stuff you can do there. But this is the new paradigm to work in analytic and in many other advanced, let's say, field today. Service in the cloud is like a package which you have the data, you have the engine to search the data, you have the analytical tool which has embedded uh, linear regression, association. All this is embedded in a service. It's like a package of embedded services. So that is the meaning of service.
Okay, thank you.
I hope it was clear. There is more about this. Uh, you can do search in Bluemix and read what they means, because in the cloud we have different way. Many people before start working in the cloud, they just think, oh, cloud is just a place I'm going to store my data. Well, this was long ago, the first use of cloud. So instead to have a big storage in your computer, external drive, you store your data. But beside data, there is already services, infrastructure, software as a service, infrastructure as a service, and we have a platform as a service. Bluemix is a platform as a service where you have access to many services, and many of them already they have built interface to connect each with other. Right now, we are working in Bluemix, which is a platform as a service in the cloud, and for assignment 2, you are going to connect two services. One is DashDB, which is database with embedded modeling algorithm, okay, with Insight for Twitter, which is another service. So this is very complex, the most last to the moment way to use technology to do analytic more seamlessly. Let's put it this way, because at the hand of the analyst, you have given all these services and the connection between them. Moreover, we had student previous semester. I will be glad if we get someone to go beyond this and to make the connection with Watson Analytics. We had in previous semester people doing this. Wonderful. Just and of course, if some then we had another student which after this class he did something for his capstones project and get external connection with Tableau. Wonderful. That is the, let's say, the contemporary way to do analytics today. Analyst gets more facility about the tools. You don't have to think much about the tool. You have to think how to use them to get, let's say, faster and more effective insight about the data. Any other question? Tracy, was enough the answer?
I'm sorry?
The answer was clear?
Yes, it was. Thank you.
Great. Great. Wonderful. More questions? Okay. If no more question, for today, I think everyone is already a little tired. So I will say some of you still have to work more in whatever, in home duty, in whatever, just to say, hope this was helpful as the way I feel, and we will have more meeting and make this class not only enjoyable, but most importantly useful for your future career. And this is all for today. Well, I'm going to be sending the song of what is Alex the Kid. So you play it. I couldn't play for you. and good night to everyone. Bye.
Thank you.
Bye.
Bye.